if the output is working. Then going to this is just simple maths. We are iterating C and will be missing east always less than equal to. We have different answer, so let's take a value. If it's A, it can be A, so A minus B or A minus. So we can always take the minimum answer. So now it's pretty simple. Yes. B minus C. B minus A and B minus C. This seems fine. I think just noticed earlier. A just to form a base case. Anyway, I did. Let's see. It's pretty fine. This will work. It's taking too much time. Let me find Really? No, it's just too straightforward. Yes, yes. Okay. Okay. Just doing like strings, fine, within enough. And then seeing going to last row first, then to first. Instead, I will go for when I don't need to check. It's just difference. It's just four. So if I see out first, that's the level 6. Four, three, two, one, two, two, four. There is no output. I don't know why. They didn't price. Seems fine. Come on, too much traffic, too much. Yes, hey, let's go. It is happening. Anti new problem now. Okay, good. Well, this finally, come on, reloading. Let's go. What? Oh, come on. I, I'm always tired on this. At least one open. And Okay. Initially, she's squeezing at X direction, then we alternate after every move. In one move, she gently moves forward in a direction. Okay, that's fine. Just a ladder, basically. This ladder, you move forward, like this that one. What is the minimum? Okay. Mm-hmm. Need to go in spots. Like use one or none. That's what it's. If he makes first, then it's always in this direction. Yes, that's it. Now he's facing right after 1 minute. Just telling that he'll either go to X direction and Y. I don't know if he can go back. That should be no. If he goes forward 2 directions, that's where it is. 2 directions like this. If he goes up another 2 directions, X2 again, small direction. Then again, it takes now it takes after she will go to 3 3 2 and her direction changes to 3, then 3 times up, then she takes 6 5 6 5, then 9 7. Okay, so how will you do this? X and Y belongs to anything. X Y can be anything. I think it's fine. If you look this way, how can I retrack back? Let I have X quantity and Y quantity. with xy, xy. I want to go to 0 and 0 to xy. I think it's about alternate options, like alternate position. I can think of is like this. What do I mean exactly? Let me show you. What do I mean? Can we prove that you can always reach? Obviously, we can reach to xy by some set of operation. So next one will do some d1 over here, the exception. So that will increase 0 to d1 magnitude. This remains constant. Okay. After that, we have to know this function y. So we can do some d2 over here, then some d3, and again d4. So like the E1 jump, the E1 we are facing the white direction. That's going to be put on d5 like this, d6 to eventually reach x and y. X continue. This was started from 0. And we are adding this. All these are we adding to make it x. This y. Okay. We have to tell the minimum. We have to tell the minimum. Okay, so if it is 0, you can change the direction. It will take 0 time, but that will count in the operation. Let's see. So how many jumps we did? So even the 0th jump is counted. If you're not aware that, if you look to what question says, you can one more. So yeah, it is valid. D0 is valid. So I think I got the idea how to do this. And we also want it to be minimum. Obviously, that we have to see which parameter is bigger. So if let's see y is bigger, then I think we have to go greedy over here. That we should take the maximum possible D jumps. D, yeah, the maximum jump we can do is D. So I think at every move we do, we should take maximally possible in our turn. Suppose it's X. Okay. Suppose it's X, but whenever you get the even even time, when you're in even time, when time the number of jump is even, then you have to obviously take these at max. Even even this will require speed if like to just reach fast as possible. So it's pretty fine. Yeah. Whatever. So first is odd, obviously, so we need to reach as max as possible. So I'll take the D such a way that you should either take entire D or There can be just two pieces, either entirely or it is x. It is x. Okay, that much we can do. So obviously this is fine. We have to just take maximums at every point. It's just pure greedy. You have to do nothing. You have to just at alternate times you have to just take the maximum. So I can just simulate this obviously. What inputs we give? X and Y and K. Okay, K is the maximum value jump we can do in that direction. So X and Y, K, obviously if that's the easy constraint. Okay, it's under the constraints of int Y and K. We'll be maintaining the operator. The number of operations have been done. It will count this. Uh, can it be zero? Yes, it can be zero. What if you are already at that particular place? As it is mentioned, it can be 0 0. Obviously, operation can be zero. Okay, that's a possible answer. So now we'll just do a flag. We'll also maintain a flag that will tell us which direction are we right now. But we should not do as a loop, which is going to give us PLE because we can't just plus it simply. We can't simulate it. We have to use maps. Okay. So x equals some amount of, so we will just divide it x with k. That will give us the amount of moves that are required that requires entire k, and models will tell us the one move that it will uh, that includes the modulus of x basically. Just like this k k at the end x modulus. Even this can come at first as well when x is less than k. That is also possible. So to formulate this, let's formulate it so implementation becomes easy. So we require exactly how many moves. These of these number of moves require is obviously x minus k plus x modulus, which is just one. I think this quantity has to be done once. This is x minus. So operation for x, if I call it as OPX, that will be x minus k plus 1 if and if modulus is not 0. If it is 0, then it's not required. Similarly for y as well. That is y divided by this 1 y modulo e. Okay. Now what comes? What is then left? Now there will be some extra. Suppose these two, or I'll say k, these two, and our x is 2, x is 2, y is 9, and obviously this will reach to x very fast. Will reach x very fast by just doing a one move. What about other moves? So we have to check that how much quantity that will be. At first, both will go simultaneously, obviously, but at end, X will get instinct whatever the minimum quantity is, either X or Y. Any one of them will inst uh, exhaust very fast, right? Will reach very fast. So if you use a correct word, will who reaches faster? Both are like going for a race from zero to zero. Right? Someone is going D, both are going at the maximum jumps as possible. But if axis reaches 5, like really fast, then at this case, what we should do? So that needs to be considered first. So how is that possible? We have to see that. I think that depends on this XK moves or YK moves. If both are exactly equal, then both require exact amount of YKs, right? Yeah, I think so. Whichever quantity is lesser will exist, will complete fast. So you have to know which one is that, who requires less operations to reach a particular point. Let's consider a case where both operation OPX and OPY are same. Then what will happen? Like both will go in maximum. This will take same amount of OPX. Then this way this it will be similar because same number like 1 2 3. Here also 1 2 3 like this. But if someone is lesser, let's say this took and we are still we have to reach. So these gets empty. So obviously we have to first count this. So it's fine. You can count this by I already told the formula on how to calculate OPX and OPY. So let's calculate OPX. I'm declaring this, which is X by K plus we'll put our ternary operator. So X modulo K, if it is greater than 0, then we put add 1 and 0. Let's give it a Y. If both are similar, then obviously that much operations are required. So if somebody is less, then we have to consider this X or anything. Fill in the void, basically. To fill in the void. What we're trying to see. So how will we do that? So cover these. Up to this point, they're same. So to just eliminate this amount of operations between both, which is just the minimum. We have to just take the minimum of this. That will give us we have to exclude. Now remaining operations or is something that has to be considered. Right? Not just y. Let's say if it was x, like This got exhausted password still. This remains this remains still going. As you can see, this is similar, same, but here only two required. In the case of Y, it requires more operations, right? Like this, then this, then this, and this. You see that the void numbers has increased by 2, and similarly here it is 1. In case of when x is greater than y and x x is less than y, means y is greater than x. In this case, we required more more voids. Right? There are more voids here. In this case, this is just only singular, and it's 2. Then you have to do it 2 twice, like that. So how will you do this? See this 1 plus, I think, yeah, it is just 1 plus, or maybe you require more. I don't know, but you have to just do a plus 1 in here, I guess, because if it is a x in 1, let's say only one operation has to be done, and can be done in 1 only, there will be 0 void that has to be filled. We don't have to go here because there's no this wasn't there. Like we don't need another thing. In this case, even you have to go for 1, then you have to obviously do x because it is where it starts. This is plus 1, I think. You have to just add 1 and that you are good to go. There's nothing more to this. So in operation, exclude what is so both are similar, then it's fine. We take the minimum. OP OPX determine of OPX OPY. Okay, that's fine. Then if let's consider all that cases. The next we will require we only require n minus 1. Okay, x minus 1. Whatever is remaining now. So let's just minus OP. Right. Let's exclude this part. And here, OP plus is this OPX, that remaining plus OPX minus Similarly here, if this is the case, then OPY. Okay. I think it's not the main, it's the twice of main. So yeah, that's misconcept. It's twice of main of OPX and OPY. And OPY will require twice of that. Even if you don't want to do, it will require same amount of X to be done, right? So yeah, like yeah, it's basically this. So I think this is enough. This is just a, I think, math. Greedy obviously involves, but it's math as well. So D4 1, I think this should come. I guess our operation is fine. We are getting operations X and Y. Then we're taking minimum of that. Minimum of that, and we're twice doing that twice. So that much, so it is required to perform that much operation. Then we are excluding from X and Y. We'll see which one has not exhausted. So X is not exhausted, so we have added this OP similarly here. So this should give an answer. Right. It's 241,779. Fine. Why didn't give the answer? I think 8. Require 8 going 8 times. Why not? Why there is no answer? Let's debug it. We might know what's not the answer. Debug. Okay, we are printing OPY. OPX and OPY. This requires 3. This requires 4. So minimum of that should be 3. 3 into 2. So operation is should be giving 6, I guess. Yeah. Yes, it's giving 6. It's definitely giving 6. Then why not? I'm not getting an answer. Okay, excluded. Okay, I'm doing twice of this. I think that's the problem. That's the issue. Let me take it to another video. So to rectify it. I don't know. I'm just implementing my code just to get a great answer. I'll take mean of that. That I'll just exclude this part. Exclude this part. Now I should get an answer. But still printing 5. Let's debug it with it more intuition. Oh yeah, I didn't add it again. You have to add it. This 10th has been renamed. I haven't 10 it. But also I have to exclude again as I already done it. So I have to make it 0 again. Then I guess I will get the correct answer. Yeah, it's 25. It's 04. Yeah, I think this is it. I don't think as there is anything required. I think it's two, so I'm think I should take silent. I don't want to get any into troubles of overflow. I think it will pass anyway, but it's just to just be safe, you know, before submitting. Yeah, this fine. This works fine. Yeah, I mean this is the only way. Does it handle cases? Let's see. Let's see. What if I'm doing one, so I'm taking a unit. I'm not going in the deep. So let's be it's 294. Let's take that. Let's take both as same. What do we get? We should get 4. Yes, it's printing 4. Uh, wrong. Yeah, it's 24. Okay, fine. If it was in this, if 3 gets more, what should we get? We should get 4. Why? We got 6. How? So this way, we got 6. How it got 6? 1. This is 1, 2, 3, 4. This we filled in the void, and then we got 6. What if it was the first piece? Then it should print 5. It should print 5. It's 3, 2, 1. Let's print that. Yes, we're getting our answer. So I think this should work. Let's put 0. This an edge case is what if it's the same thing? Yeah, 0. Fine. We're just making sure again. So we'll think to the operations that we're doing, making it 0, then putting into if else and checking cases and adding the appropriate ones and then adding the temper. Yeah, this works fine. Submit it. Taking too much time. I don't have that much time. So just be back a bit later. Still not reloading. Come on. Okay, fine. Finally, this game is this temporary block. Like, then how will I get problems? Hmm, that's crazy. I think there's too much traffic. That's why I'm unable to load my page. Uh, I didn't like, I was hate in day post because of this issue that happens. When you check this structure, and this is not working. Like, at least I should get a verdict. I haven't checked my verdicts as well. If they are correspond, like how will I evaluate? Okay, you can't see it. Really? Okay, let me start. And start. Let's it's not even thinking like not even starting like how will I understand the concept? It's really unfair. Like okay, now it's okay. Still can like watch my submissions. Like if there is any way I really hate it. I should not give force anymore. I think that then this should be my last. No, not actually. These right upsides are not working. How should I even like, loading then blocking the page? Like, how should I submit? I'm running out of time, right? I can't see even problems. That's the issue. I don't see problems. Like, okay. This website is like nothing else. I should get see again on the relay. The traffic is real. This is quite real. I think they should not have these contests because of the high rated players also participate. Like why? I'm not gonna click on that. Um, again, like really, like who's the administrator? Like let me be in. Like I'm sitting. What? See, this is unfair. Like this is has now haven't happened for a long time. I'm seeing this first time. And I'm running out of things. Like, it's already been like I'm completely I can't do anything. These libraries are not working for me. Like, even this third, like, not working. I haven't seen B right. Can't see even see if my solutions are right or wrong. Mostly they're right, but at least I should get it checked. Oh, it's not working. This is really, really, really I'm not going to. Okay, now I can enter. Now I can enter really. Like, what not happening? Finally. One is one and distant points one to it is guaranteed y for all given points. So it's either zero or one. How many different non-degenerate right triangles can be found from choosing three different points? That is what it is. Maths. Okay. So like y is remaining one. I can see the visualization. Okay. So I have points. Four triangles question. Basically, it tells me that how many different writing a triangles that I can create. Using three different points at vertices. Okay, so we have to just form rectangle triangles over here. Right. Can it be seen? Okay, we were given that these are distinct points. We have to tell the count, basically output the number of distinct integers, non-degenerated right triangle. A non-degenerated right triangle has positive area and an interior 90-degree angle. It means right angle. What else? How many? Um, so yeah, points should be different. Like the set, at least one should be differ from others. That's what it basically tells us. And from five, it has generated four of them. What if it was one? Then if there were only three, the suppose, but at least there should be one upside. Like if both three of them remains downwards, then that will not be any point. So like to become at least one triangle, we need 2 points x1 0, but x0 twice, and at least one x with 1 requires one time. So this will generate at least one triangle. This will generate at least one triangle. That is for sure. Let's see if I add, if these are 3 in the quantity, and if there is 3, how many you can make up from 1 point? So you can make from this, you can make from this, right? I think it's pretty similar. It's very easy. If you consider any like y number of these points where the y-axis is 1, there are like m points out there, m points. The below there should be at least 2. First of all, this downwards are those which has y as 0, and that should be greater than equal to 2, because if it is not 2 and this is not 1, then both ways we can never make a triangle. Yeah. But also they consider that there can be an angle upside as well. This can be also possible. So how many you can make from this? If you see over here, how many you can make? So I think it's simple. So consider this. Let's say there are 2 points up and 3 points down. That's the basic case. Just take this point and make a triangle here, then make another triangle here. So how many possible sets there are possible of taking tools in below? You have to take tools, right? How many ways we can take tools? Here, what do you see? I can take this tool, I can take even, but I cannot take this. I cannot take this because this has to be maintained. If you see, if you see that this should be maintained, right? So I have only, so whatever, let's say here there are b b number of them. Yes, obviously these should be greater than the 2 for right now. Like we are considering, we are uh, imagining from top to bottom this projection. Like in this, we should require to. What if there can be also inverse? Like if we look this entirely in a in the other direction, then A will become. Let's consider the number of uh, points should be A, then A should be greater than 2, like this, likewise. So that condition will satisfy. So I think it's more of combinatorics. So if you just code it right now, so if you just make it for formulate these, and how many I can do. So particular point can actually do b minus 1 triangles from here. If there are 3, then I can make b minus then the next one has to be all, but the condition is that both of them should be aligned. That is the main issue here. So to find those points which are exactly like parallel to each other, like right now, like if you we can draw a line and here maintain this distance, that should be 90 degrees. So those points has to be found. How can that possible? Then obviously both has to be satisfied the x quantity. The other ones can be anything above this. No issue in that. How will you do this? Uh, yeah, it's fine if I know the numbers here, and I can then just find and can just move forward. So the main advantage, this I need to get this price first. No way I should get this pair first, maybe then these are possible. I'll get a random inputs of different numbers. I should define a vector. Vector with int. Let's make it int. There's no require for them right now. I can maintain two. That's also a way. I think I can do a lower bound. If I can find the lower bound there, then that should work. Simply, I don't require it. Let me see. X can be n. N is possible. The n are in the constraint. So I should print it from 3, 0 to 3, or similarly like that. If it exists, to do in the similar fashion. Like, like this, and then this to n, this n. Yes, I think yeah. X is n. So that is gives us the idea. This will be a data structure problem. I think there I do some vectors, pairs, map. I think it's fine. This is fine. So I need to give those points, those have same x on the upper side and downwards. Those are really essential. Let me see beginners how they are formed. Okay, also this is also possible. 90-degree from here. This is one, obviously, this is one. This can be anything else from here. Using the reference, the points, or the possible points we're considering, linear points. I think there's only one that's possible, because all of them are distinct, right? Not held properly. Given n distinct points, n distinct points, okay, that will be similar. Can this be tilted? This is the point. Maybe this is, and then might be this, like this. Possible. But how will I find this? That's the question. How can I ensure that this is possible? And if I'm doing something wrong here, maybe I should look this way, not sure exactly how should I proceed with this. This can be possible. This can be. So I can here from here, I can know this is one, and then the length of this, and the length of this is length. That's your hypotenuse. And this makes 90 degrees open. This seems to not have very trigonometric. Yes, it's basically like reference to that. When you see how many people solve it, I think it's an intermediate problem. Not not very not medium problem. We're given NBC, okay, given that. Do we really to check this triangles? Okay. Because, because this can be found easily. Those which are at 90 degree. There is one side which is 90 degree. In these cases, all sides are neither in the 90 degrees. Like, okay, but this is we can ensure that very easily by this is x and find the x from here. That will be your count. Or you can do the upward way as well. That is also you can just check backwards. This, then this. You can do similar at here. You do similar thing. Let's find this. It's fine. Both ways you can uh, check it. One this way and one this way. So you get the count of these triangles. What about these where they are tilted at this point? Let's say there's some degree from here like this, and then this, like how this is possible. There should be some similarities, some points. There should be something. There should be. I can use the trigonometry here. If I know the distance of this, I know the distance of this, I know the distance of okay, I don't know the distance here. I know the distance of this. I know this, and this. Similarity of Pythagoras. I can imply that here, imply that over here. That will give me the hypotenuse of something like E, this case Q. Yeah, I think yeah, I can verify this. So if this part and this part, both summation gives me 90. This gives me 90 degree, gives me pi. So that I can verify this. How that will be possible? Let's suppose, okay, I have to consider something. What will be the angle of this? That will be P Q hypotenuse. So P by Q, P by Q, E should be equal to this ratio. No, this is not ratio. This is summation because okay, that will give us a trigonometry now. So it will give me sine alpha. Alpha you can say this in alpha. The alpha then with sine alpha E by Q. And then alpha will be the inverse of that, inverse of this thing. So if you formulate this, then like if sine inverse of E Q and plus sine inverse of RQ, RS. Consider this in RS. This is the case. Okay, wait. Can do cos phi as well. Why am have to calculate this? So, to find this angle, we take the adjacent, then the above number. Adjacent, and the hypotenuse. Okay, that is 10. Yeah, that is 10. In 10, I can have R above the opposite side divided by 1. It is the adjacent side. Similarly, I can do here P is plus the summation of this tan inverse. Okay, I'll find a tan inverse of these two. That should give me tan inverse of 90 degree. Okay, not tan inverse of 90 degree. So I went again. Wait, what is 90 degree? That is pi by 2. So if this comes out to be exactly pi by 2, then I think that is fine. So we will get a pi by 2 over here. Then I think this is confusing. I don't know. Or if I'm doing something wrong over here. No, I think that's fine. We can do that. As you can see, this making these are answer in the past, so all possibles are happening over here. But I don't think that is even required. I have to find some relation over here. So where this 90s making, I have to consider that. How do I find that it's 90? How do I ensure that that these 3 points within the 90 degree um, from here? Okay, fine. Then I don't think that trigonometry case has to be handled. I think this is easy. Considering it's live for live, this should be easy. So I have to handle this case. The first case is very easy where I think if both are axes similar, then I have to just consider all the points from here, all the points that I traversed so far. I have to just for loop of this. If this is available, we'll check that. So I have to make n n vector, n size vector, n size vector where I will maintain both of them. Anyways, so also I'll take that counter how many from here, how many from here. Similarly, if I again encounter something similar again at a further point, you can check. This is first part. This is the thing that the 90s how the how points are related to 90. That has to be checked. Also should be done in n as well. Maybe in n. I think that's the constraint. Okay. Or in n log n in the worst case, but should not be less bigger than that. I think. I think how to do this. How do I ensure that this anything I think I should do some search reason they forgot on it. Let's go. I don't need to worry about my reading now. Thanks. But we still solve it. Uh, this is crazy. Anyways, that's very hilarious. It never happened. Like this is the first time happening. But yeah, I understand. Like very beginner players are coming here, so the traffic is huge. Traffic is huge. I think they too many complaints have been reported. This might be the reason. I think they did a good job. I think. Yeah. Okay, let's focus on the problem. Let's see if we can find some blogs over here. I can find this. I know it's math, but I'm very poor at it. Like, really. I think Google should help me on this. Okay, finally. Check whether triangle is very 103 points right angle. with only coordinates three don't form, they don't form a right angle triangle. For a Pythagoras right angle, they did a matrix way. Given the side right? Okay. You think, you think, yeah, it's calculate E is the largest side. I think we'll solve it later. Yeah, I think there is a relation to this. The other way is, I already told that consider these two cases. That is this. This is fine. We have already done it. Like, if this is here, we can get the count. We can get the count. We can go again. We can get the counts again. Likewise, this is the case that we have to. Second case. Let's solve it. Like, we have some time. Yeah, we can still solve. How do I make sure? How to know if 3 points make out right on the time? I have to find the distances basically to determine the distances. Okay. The two of them is focus. I think this before is a bit hard. On C or notes it has gone really hard because it's greedy and not. It's not that big enough value, and it wasn't that much. I felt like 1,000 to 11. And now it's little. I'll take idea. I think I should discontinue. This should be. I said later. I think it's easy. If I see, I already told that you can get this. It's very easy this way. Only this way is something that is. I think they told about they they're telling that this is the side, this is the side. It's at one side. two sides has the square of these sides uh, makes a right angle triangle, then that will be we can get the size lengths like x, y points considering like that. We'll just consider the above one to get all this, this and this. One is above, like one point is P1, this P2. Obviously, they are not necessarily here. P3 that is ahead of it will be in the downward portion. Like this is P3, this is P. I can get the length of this. Okay, I have to consider P's length. So this should be a hypotenuse. This should be a hypotenuse. Yeah, it should. Okay, this is right angle now. So if I want to make this right angle, this has to be, this is the hypotenuse, right? So that's like P2 by P3, right? This should be the square of these both, right? P1 by P2 square and P1 by P3, I think, yeah. So I should get the linearity distance, like Euclidean distance between these, which is like really not a big deal. And the distance of this, the of this, and these points mentioned. If this satisfies, I can get the answer. Yeah, this solid data. Yeah, I should stop now. Maybe I should just stop this. Yeah.